Lesson 5 of Chapter 4 is on graphing the other trig functions. We've already gone over graphing sinusoids, that is sine and cosine waves. And now in Lesson 5, we're going to graph tangents, cotangents, secants, and cosecants. Part 1, we're just going to start off by graphing the tangent. You can see here is a picture of a tangent graph. Tangents have asymptotes, and you can see that they are located at the half pies. All the specific details of the tangent function are located on the left. The range of a tangent function is all real numbers. You can see the x-intercepts are at the pies. The y-intercept is at 0. This is a discontinuous function because of the asymptotes, and the asymptotes are located at the pies. There is symmetry of the origin, which makes it an odd function. There's no extrema, no mins or maxes. And then the end behavior does not exist because it's a periodic function and it oscillates between values as you go really far to the right or really far to the left. Now, with that being said, this is a picture of one period of a tangent wave. So the period of a tangent is only pi, or 180 degrees. So you know how with sinusoids, we have period equals 2 pi divided by b. Well, with tangent and cotangent, we're going to use the equation period equals pi divided by b. And we're also going to be talking about a, b, and c values, or values that affect it vertically, horizontally, and then shifting as well. So let's start off by graphing a tangent of 2x. Well, that 2 is going to affect the graph. That's going to be a horizontal shrink of 1/2. So how I do this is I figure out where the asymptotes are located. Normally the asymptotes are located at the half pies. But now since we're shrinking this by a factor of 1/2, I'm going to multiply each of these by 1/2, and I get pi over 4, 3 pi over 4, and 5 pi over 4. So since those are the asymptotes, I'm going to put those on my graph. Actually, I think it would be better if we did this. So I'll set up my graph this way. I'll make this 1 and this -1. And so we'll put an asymptote at 1/4 pi. Now 3/4 pi would be 1 box over, so about right here. And you can see that each of these asymptotes are 1/2 a pi apart. And so now right in between those asymptotes, we plot the x-intercept. And then right in between the x-intercept and the asymptote on the right, we're going to be at a height of 1. Right in between the x-intercept and the asymptote on the left, we'll be at a height of -1. And then tangent's an increasing function. So as you're going left to right, it's an increasing function. So there's 2 period lengths, or 2 cycles of a tangent wave. Next example, you can see that we've got 2 transformations. We've got a vertical reflection with the negative sign, then we've got a 1/2 in front of the x. So that's going to be a horizontal stretch of 2. So again, the asymptotes are normally at the half pies. But with that horizontal stretch of 2, I'm going to multiply each of these by 2, and we'd have them at the odd pies. So if that's where the asymptotes are going to be, I would set up my x-axis. So I'm going to set up the x-axis like this. And the vertical scale like that. Putting the asymptotes in at the odd pies. So now right in between these asymptotes, again, we've got x-intercepts. Now normally tangent's an increasing function, but with the negative sign, it's a vertical reflection, so that's going to make it a decreasing function. In the graph would look something like this. So I always plot 3 points when I graph a tangent wave. You can see those 3 points here. And that helps me get the curve aspect to it. It really looks a lot like a cubic function. So there's 2 examples of a tangent function with transformations. Here's another tangent function. This one has a shift to the right, 3 pi over 2. So again, the asymptotes are normally at the half pi's. But we've got to shift everything to the right, 3 pi over 2. So if you add 3 pi over 2 to everything, we'd get 2 pi, we'd get 3 pi, we would get 4 pi. So that's where our asymptotes are going to be located. And so when I set up my x and y axis, I would set it up let's maybe stretch this out a little bit more. You'll find that using 2 boxes to draw a period length is okay, but it's a lot better to use 4 boxes. So I'm going to make that pi. This is negative half pi. And so with that being said, my vertical scale, I'm going to keep it the same as 1 and negative 1 like that. I have an asymptote at every pi, so 0, 1 pi, 2 pi would be about right here. So now this is a tangent wave, which is an increasing function. So I'll plot these 3 points. And there's one period of the tangent wave. And here is a second period of that tangent wave that's been shifted to the right, 3 pi over 2. So there's 3 examples of a tangent graph. So now let's go into a cotangent graph. You can see cotangent is very, very similar to a tangent, except for it has asymptotes in different locations. This time, for a cotangent, the asymptotes are at the pi's, whereas the tangent has asymptotes at the half pi's. Also, cotangent is a decreasing function, where tangent's an increasing function. You can see that on the graph on the right. All the details are on the left. You've got range, which is all real numbers. X-intercepts are at the half pi's. There is no y-intercept. It is not a continuous function. As I said, you have asymptotes at the pi's. There's symmetry of the origin, which means it's an odd function. There's no extrema, and there is no end behavior. So here's an example of a cotangent. Well, we want to figure out where the asymptotes are. Normally, the asymptotes are at the pi's, but we've got a horizontal stretch of 3. So if you multiply each of these by 3, this is where your asymptotes are going to be located. So when you set up your x and your y axis, I would probably set it up this way, making it easy to identify where those asymptotes are located. So first one's at 0. Next one's at 3 pi, 6 pi. So every 3 boxes we have an asymptote. Now remember, cotangent's a decreasing function, and its x-intercept is right in between the asymptotes. So there's your x-intercept. And then your height of 1 is right in between those. So that's going to be about right here and about right here. Then draw your decreasing function going through those points. That is one cycle or one period of the cotangent function. And here is the second cycle of the cotangent function. So as you can see, the key is to simply identify where the asymptotes are located.